So, somebody remind me to turn that off when it's time. This section will remind you totally of pre-calc. Okay? The difference between the exponential decay and growth what we did at pre-cal is we won't start with the diff and Q like we do in calculus. Okay? So, but the problems are going to look similar, but again, it's the approach. Okay, so remember, population growth is directly proportional to the number of people, which is what this means. A direct proportion from algebra 1 is y equals kx. Remember that?
Is that what we changed the constant to k to u?
Yes, that's part of the reason. Yeah. Okay, and so anyway, the rate of change of p, that's your derivative right here, is directly proportional to p. Okay, so in general, y of t is the value of a quantity, and the rate of change, of course, is proportional. Okay, we're going to call this the law of natural growth if k is greater than 0, but of course it's decay if k is less than 0. Decay is your growth rate. Okay, it can be positive, it can be negative. If you have negative growth, you don't really call it growth, you call it decay. All right. So I left you a little space, but let's solve dy dt equals ky by separating. I think I spelled that wrong, but anyway. All right, so what do we do? First, dy dt equals ky. Do what? Okay, so how do we do that? All right, we start cross multiplying, so that'll give us ky dt. Yeah, you can divide by ky, but the k can just stay right where it is, too, either way. Okay? All right, now we are ready. Sometimes it's easier to see something rather than nothing. All right, now we're ready to do what? Integrate. Good. Okay. All right, what is the integration of 1 over y dy? Job and k. In terms of t,
K, would it be KT?
AT, right. All right. We're solving for y. E to the
KT is or would it be K to the KT? Can
Well,
we use K this time?
okay. Now, this is the natural progression, right? Okay. This is our, usually we call this y sub 0, or we called it initial value. Oh gosh. E to the KT, and that should look familiar. Does that look familiar to you?
Something's wrong with your board.
Yeah, it's a little delayed.
No. You have the E, but you have like a little U next to it.
Yeah, it jumped up when I.
So Y sum
Y sub 0. Y sub 0 is usually the initial value because we're talking about what this started as. If you'll remember it when we go on, I'm pretty sure.
So use that instead of K.
Yeah.
Is this like what we did with the
Okay, well, you'll think of it.
with everything else, do we use the Y here instead of
With the decay problems, you will.
okay. Like that.
Yeah, for the growth and decay problems, you want to use this, and then the K will show up somewhere else in the other ones. Okay? So that's, now what, so basically, you should probably still right here. Basically, the solution of the initial value problem, these aren't going to look any different. This, remember, transfers, we just got it to this. These are equivalent statements, just saying. And then y sub 0 is the same as y of 0.
So
Okay.
you can remember that you are these KY.
It would be helpful to remember, because if you can remember, then you don't have to do all that. So good question, Molly. If you can remember that that equals that when you integrate it and do all that, then you don't have to work through all that. And that's the difference between the pre-cal that you'll see and the calculus, is that sometimes they'll give it to you as a DBQ and you'll be like, oh wait, that's the same as this. So that would be a starting point here instead of there. Okay? All right, so let's try a couple examples. I put, what's going on here? I put some, these are, see, celebrity. That's you. I'm a celebrity. In my own mind. So, what do you got now?
She became a celebrity when she was
That's right, that's right. Okay. Scientists observed 125 bacterial colonies growing in the, I thought it was agar, but anyway, of a petri dish. Exactly 6 hours later, the number of colonies has grown to 190. Okay. We want to construct a mathematical model, which is just a function. Okay. That describes the number of bacterial colonies present T hours, so we have to use the T, after the start of the experiment, assuming exponential growth. Okay? All right, so here we go. Usually the first step in the K growth problem is to find your K. All right? So what do we know about 125? What would you call that?
first initial value.
I would say, good job, Sarah. That would be your initial value. That's what we started out the thing as, all right? What about 6? Of course, that's time. Okay, and what is 190? What is it? Y of 6, right. Okay, so we're going to find our K. It's, we have pretty much, K is unknown, T. If we find K, we have our mathematical model right there. Okay, the 6 and the 190 is going to help us find our K. Do you remember this?
Yeah.
Okay. All right, so Y of 6, where are we going to put the 190? Right here. Okay. E to the K times 6, or 6K. All right, go ahead and solve. Yes, you'll have to be careful about rounding here in the middle of the problem. Just leave it exact if you would, please. Leave it exact. It's going to be ugly, but that's okay. Don't worry. We're not allowed to do. Y'all remember when I had hair like that, kind of? Yeah. You don't have hair like that. It wasn't like that color. It was kind of short. It was strong like that. Yeah. I'm looking for, I'm just going to do it here while you all knew it. That reduces, but I don't care about it. Yeah. Yeah, it is gross. It usually is.
Is it okay if you separate it to ln 190 minus?
I wouldn't do that. I'd leave it.
Sarah, don't make it more complicated.
She likes it because she thinks she likes it because there's some bacteria. That's literally the only reason.
No, she said something about construct a mathematical model, and that's like
Her words, yeah. Okay, so everybody, did you get this for K? Looks about as simple as 190 over 125 is 1.52. Anybody not get that?
Oh, I just put it as the.
Which is fine. It usually is the nasty fraction, so it's usually better that that one is. Okay, so if we wanted to, if we were simply leaving it alone, the 125 would go here. This is our mathematical model. E to the 1/6 ln of 1.52. Don't forget your T. Okay. This would be fine. Okay, now there's an E and an LN that we could maybe look for in a multiple choice question. What if that's not there and it looks quite different? What would you do to simplify? I'm okay with this, just FYI. In an FRQ, it's totally fine. But on a multiple choice, what would you do?
Would you do, first you'd have LN, or you'd have LN, like parentheses 1.52 to the 16, right? Because you'd move that to the exponent.
Yes,
And
very
then
good.
it'd all be, you'd multiply by t, but then you could, cancel out.
Okay, very good. So that's 125. And what does the rest of it look like? 1.52 to the 16?
Yeah.
And the t is up here or down here? Okay. Now, I wouldn't do that, sorry, I wouldn't do that unless you were looking for a multiple choice answer that this wasn't here. I would just leave it alone like that. Even, if you want to do it like this, that's totally fine. Okay? So don't spend a lot of time simplifying that. That's totally fine. Right. So that's your mathematical model. All right. This is a continuation. So approximately how many bacterial colonies will be present exactly 1 day after the experiment begins? All right. Our mathematical model, we're just going to use e to the 16 ln 1.52 t. All right. Where does that 1 day go? T is 1.4. Ah, you're so smart. Okay, so T is 24 because the unit is hours, not days. So you got to do 24 hours. Okay, so we plug it in. Yeah, you'll definitely need. And this is the time where you may want to store your K, just because it's annoying to plug that in all the time. Do you remember how to store? No. 1.52. Divided by 6. Store alpha K. All right. 125 e to the power is that one rather than the caret alpha K times 24. Okay, so what you got? All right. And it says round the answer to the nearest integer, so that would be 667 colonies, right? All right. Assuming that resources are a non-limiting issue to growth. What does that even mean? Like, right. Like eventually the petri dish is going to get it's going to get full, and then they won't grow the same way. But we're assuming that's not an issue. How many hours will it take for the total bacteria population to reach 20,000? So again, we're working on this. I'm just going to put K here. Where does the 20,000 go? Y. Okay. Go ahead and solve it. Why?
I'm probably going to say it to people in the call.
I've said it before.
I said it, and people look at me like
I'm
I said
sorry.
it before.
Because it rubs off at me. Yeah, because you rub off on us. Yikes. You made a mistake. It happens.
What? That was the next question. Are you rounding it out?
that what you're doing?
That's what I got. I did
Okay,
that
I
one.
must have done it out of order. 'Cause I probably, yeah, I get negative answer. Oh, because I put K in here, not in here, too. All right. So, let's see. ln 160 divided by alpha K.
So we confused.
Okay?
How did you get the ln of 160 over K?
Right here, you take the ln of both sides. And then that becomes KT equals ln of 160.
I would just rewrite it like okay. Yeah. So do you suggest like for the almost just think
Let's see. I just don't do that.
I know.
Okay, did anybody write this in terms of ln from the E instead of taking the ln on both sides?
No.
Okay, what do you think about it?
I just want
No, it's okay. It should work out. ln equals KT, right?
No, I just did
Of 160. So you get the same thing.
I just did that. That's basically what you did right
So I'm just gonna, yeah, that.
You just wrote
So you
this
did it
down.
wrong.
Yeah.
Okay. Yeah, so you can do that. I just don't think that way, but it does eventually get there. Okay? And, what are we doing? Rounding to the nearest integer, is that right? It is. What?
Almost ready to use the 1 a.m. on the 4th day. Well, they didn't tell you.
All right. Okay, so we don't have to work through this whole problem if we don't want, but the half-life problems are exponential decay. Okay? All right. Construct a function that models the remaining mass. All right. We know we have exponential growth and decay. That's where you should start. Okay? What are we going to do to find k? Because that's really all that's missing in any kind of growth and decay problem is to find our k. Okay, what are we going to use? A half-life. We have a half-life of 5,730 years. So what do we want to do? What, Abby? Okay. Okay, can you help me out a little bit more with that?
T equals 5730.
T equals 5730, okay.
And y would equal 1/2, or, yeah, is that right? Y would equal 1/2 of y of 0? Yeah. Yeah.
I mean, you can put 50 and 100 in, you can put 25 and 50, whatever, but this, regardless of what you put in here, right, if you say, okay, I'm going to start with 100, then you're going to have 50. The first thing you're going to do is divide that 100 out and use, 1/2 equals e to the 5730k, 5,730k. Okay? Yeah, you did that last year. All right, so go ahead and find k. This is a decay, so k should be negative. Holy time.
Dude, I don't like the numbers.
Is it negative?
Yeah.
What?
I have it on
0.5?
0.5. Okay, it looked, sorry.
Oh, sorry.
Looked like a 5 at first.
All right. Glad you feel comfortable to question me, even though I'm not wrong.
No, I'm getting yeah, because it looked like a multiplication dot.
Okay. Now, I also, I think it's a good idea to kind of keep that. Yes, thank you. That was my point in doing that. So people write this and then they'll, oh, whoa, that's quite different. Okay, so let's see, what is it? Negative 1.0 times 10 to the negative 4. Okay. All right. So be careful about that. That was exactly my point. Thank you, Emma. You fell right into it. Yeah, I want to make a point about each of them. Yeah. All right. So let's lie. What am I looking for?
After 2 years.
Okay. So that's your. So y equals.
Constructive function. That's what you're trying to do.
E to the ln.5 times t. Okay, and that's totally fine.
Whoa, man.
Oh, sorry. So my man.
What's the difference?
Whoa. Okay, and we have this. Go ahead and store that in your calculator right now. This is the last thing you did, because you don't want to have to mess with that again. Store it, alpha K. Stove, right there. Some stove. Okay. Yeah, we have it. Okay. All right. Come on. Whoa. Okay. Do that one, and then we'll go to AP problems. Because I think I could have been and put them on my recap one. Right? So where'd the 300 go?
Initial value.
Initial value. Everything else is filled in, so
You just have it.
yep. That's your. So 300.
Oh, my sorry. I was thinking it had to be tiny, but never half like it's huge.
Right. It's going to take you a long time to get to the 300. Yeah. Alpha K times 250. So what you got? 251. 9 what?
291. 0.063.
Okay. All right.
Do we have to do the multiple choice homework too?
No, we're gonna do it right now. Okay. All right. So read the first one. These are from I forget 2003. Journal 9. Calculate the first two. So third one. Rate of change is directly proportional to the square root of the volume. Okay. Really nothing to figure out. You just got to read the words. Which one do you like? The rate of change would be one of these guys, right? So these are done.
It's E.
Okay. Directly proportional to the square root of the volume, which is, yes, it is E. Okay. That's a multiple choice question. That's an easy one if you can read, I guess, and
You remember it.
it's not. That's what I get. Right proportion, remember, is y equals kx when we first started algebra 1, so this is just a little bit twisted. All right, now this one's a little bit more complex. A curve has a slope of 2x plus 3. That's the way that one Allie started today. What does the curve look like? Remember? That when you did on the board, it had the same language going.
Oh, it's.
Yeah, so this is 2 I dx equals 2x plus 3. Okay? Which of the following is an equation for this curve? So what are we looking for? Y equals, that's your equation, if it passes through 1, 2. All right, so I'll give you a minute or two to work it out. I had it worked out. I'll give you a minute and then I'll start on it, so it's there. It should be one ABCD. You can check with me.
You say it should be ABCD.
For me.
Well, that's where it's changed.
Why is it green?
Those are the only options.
Right. But I was just reminding you of more choice, so you didn't get one. I know you don't need to be reminded
The
of that.
first one you would get if you can breathe. The second one you get if you one of your options is answer choice.
All right, Molly. All right, very good. Everybody's getting the right answer. Okay, good work. All right, so we're going to separate, right? And then integrate, separate, integrate. Y equals x squared plus 3x. Let's see. I am. One, change those. Oh my God. I'm sorry. Is that what you got?
Yeah.
Which is,
Isn't it?
this is my general form. Did you make a mistake and get one of those answers, Ally? Oh, okay, you did it differently. All right, now, remember Newton's law in pre-calc? Okay, it was ugly. All right, well, this will be like Newton's law, but they give it to you differently, so you don't have to memorize that big U of t and ut minus u of 0, all that. Okay, so but it is Newton's law. It's just approached a little differently. Okay, pizza heated to a temperature of 350 degrees Fahrenheit is taken out of the oven and placed in a 75-degree room at 0 minutes. The temperature of the pizza is changing at a rate of 110 e to the negative 0.4 degrees Fahrenheit per minute. That's a rate, so that's a, what do you call it if it's a rate? Derivative. Good. To the nearest degree, what is the temperature of the pizza at time t equals 5? Okay, so what do we know here? This is calculator driven. Please pay attention, those are rounded, so probably. What do we know? Anything, anybody?
Oh, do you want to sort of say what?
Yeah, I'm just gonna start you out and then, because this is a rate, so what does that mean? It's a derivative. Okay, so what is the, let's see, temperature, T dt, right? Big temperature difference in the time frame. That's what that means. Okay, equals negative 110 e to the negative 0.4 t. And agree, yes. It's a great. I was just, what is that? Okay. This right here? Yeah, I had it somewhere. 1 divided by
It's 275.
Which I said.
Because you're dividing by a number smaller than 1,
Yes.
so it's gonna be bigger.
Well, there was stuff on there, just smart aleck. It's 2.5.
110.
Oh, they're right.
Oh, she's trying to do that.
Oh, I just did it. Wait, I just did it times.
I know.
You said I just thought about it in my brain.
Is that where you're like?
What's that? Is that the negative 250? No.
275.
Okay.
Also.
It's positive.
Yep.
Well, that's interesting.
I didn't do it this way before, but.
I got what you got.
Okay, did you get?
Nope.
Why do you have that in brackets?
Because I just do that for my antiderivative. I don't know why I just do sometimes. Okay. Now what?
You just said the time equal to 0.
Okay. Time equal to 0 and temperature equal to 350, because that's the initial temperature when you took it out. Good knowledge. All right, so 350 goes here. E to the 0 plus C. C equals. Okay. So is that 75 degrees? Clearly not. It's just 75.
No, it's saying that C is 75.
C is
Oh, sorry.
If you had the regional equation with 5 and your T.
Right.
And your VDT.
ABT, I like it.
This is a multiple choice.
Yeah, some of them are really intense. Remember I told you the Diffie Qs were the weakest link of the whole test? Because some of them were like this. Okay, now what? Plug in what? Sarah, did you say it?
5 for a little T.
Okay. So, oops. What is the matter with me, Ally? All right, thank you. Now, did anybody do it? We did not. Never mind. I'll finish this and then I'll. 275. Did you finish?
Yes.
Okay. 5 minutes.
Alright. Wait, so
I agree.
can I ask a question?
Uh-huh.
Okay, so.
I'm touching these guys so I can hear you.
Okay, so can we, like, is it reasonable to assume, like, without solving for the C, that, like, this 75 is gonna be that initial condition? Like, is gonna be the, like, is going to be your C?
Because it's over in
Because it's the room temperature, so, like, you're
Oh
going to
my
have to add
goodness.
75 to it?
Seems reasonable. Okay, did anybody think about doing a definite interval, because then we could do it over here?
Oh, boy.
Let's think about a calculator, a definite interval. How would we do a definite interval? This is alternative method. Okay. When you're 0 to 5, this.
Yeah, and then do it in, probably have to subtract that.
Because
That's how much.
that's, I would say, yes, because you start with 3.
I feel like once
You
you
would
got there,
do
you
it.
would figure out
Yeah,
whether or not.
You do whatever it would take to
Add
get
it
it to be
to
lower.
get lower.
Which is
You
really
really
what
want D as a
Once you
choice.
get out of that. You go.
Because that's what 350 minus.
You think I, or.
I like doing the C better because I get confused on the definite interval.
I think the
It's just to be quicker to do the definite interval because you can do it.
Right, but if I get it right, does it matter if it's faster?
I want to run out of time to do the rest of the problem. That'd be the only thing. Okay, so I got negative 237 when I plugged this in. Did anybody else do that?
Yeah, then we said, well,
Okay,
if
ish.
you subtracted it, you would get the 112.
Okay.
Yeah, 112.
So, no, you're
No, you added because
You're
it's already
adding.
negative.
But
Yeah.
zero.
I felt you were
350 initial temperature plus a negative 237, blah, blah, blah.
That's basically projecting.
No, it's not because you added.
Adding
You told me to subtract it.
subtracting something.
But if you told me to subtract it, I would have put 350 minus that.
True. You're all right, you're wrong. Come on, admit it.
Say it.
Say it.
If you subtract that number, you're basically adding.
But